Here are the answers for the homework for section 8-2. We're asked, what is the slope of a line that is perpendicular to a line through the given points? What we know about slopes of perpendicular lines from this lesson is that the slopes of perpendicular lines are negative reciprocals of each other. So our technique can be to first find the slope of a line that goes through these 2 points, and then after doing that, find the negative reciprocal. So let's get this slope using the slope formula. y2 minus y1 divided by x2 minus x1. This is x1 and y1, and this is x2 and y2. So subtracting the y's, we have 2 take away 1. Subtracting the x's, negative 3 take away 2. This makes the answer 1 over negative 5, which is the same thing as negative 1/5. What we have figured out is the slope of a diagonal line that goes through these 2 dots on a grid. What the question is about is, what would be the slope of a line perpendicular to that? So let's find that next. Slope of a perpendicular line. This little upside down T symbol means perpendicular. So this is just a quick way to write slope of a perpendicular. It will be the negative reciprocal of negative 1/5. So when you take the negative reciprocal of something, you change the sign, that becomes positive, and you flip upside down the number. It becomes 5 over 1. This is simply 5. Number 3, let's follow that same technique. First, find the slope of a line through those dots. So 3 take away 3 makes 0, and negative 3 take away negative 2 makes negative 1. And 0 over negative 1 is 0. Okay, a line through these dots has a slope of 0. It is a horizontal line. Now let's get the slope of a perpendicular line. Well, perpendicular to horizontal would be a vertical line. And the slope of a vertical line is undefined. If we were to take the negative reciprocal of 0, we tried to flip 0 upside down, that would make a 0 in a denominator, which you can't have. So that's why the answer is undefined. Number 5, let's first find the slope of a line through these dots. From negative 1 to 5 is a change of 6 units. From 5 to 7 is a change of 2 units. This reduces to 3. Okay, if this line has a slope of 3, what would be the slope of a perpendicular line? Let's do the negative reciprocal of 3. So the negative of a positive number makes negative, and the reciprocal of a 3 makes 1/3. Number 7, find an equation for the line that fits this description. Our line is going to go through the point negative 3, 4, and it's going to be perpendicular to the line given by this equation. So as soon as we see perpendicular, let's think about this idea of slopes being negative reciprocals. If we find the slope of this one, then we can do the negative reciprocal to get the slope of our line. Okay, this equation is in standard form. To find the slope, we can use the formula negative a over b. So this is negative 2 over 4, which is negative 1/2. The slope of a line perpendicular to that is the negative reciprocal. So that becomes positive 2 over 1, or simply positive 2. We have a slope and we have a point. And from those 2 pieces of information, we can get an equation. Let's use point-slope form that we learned earlier this year. Y minus y1 equals m times x minus x1. So we have y take away 4 is equal to 2, and then x take away negative 3. Let's fix this negative negative in there. We have y minus 4 equals 2 times x plus 3. Here's an equation in point-slope form for our line. Number 9, let's make an equation. And here's what we know about the line. It goes through the origin, and it's perpendicular to a line through these dots. Well, first, let's get the slope of the line through those dots. From 6 to -1, the y value is decreasing 7. From 7 to 2, the x value is decreasing by 5. This is 7/5. Now let's get the slope of any perpendicular line. It's -5/7. It is the negative reciprocal of this one. We know the slope of our line, and we know it goes through the origin. We can use point-slope form again, or we might even use slope-intercept form. We have y equals -5/7 times x. That's the quickest way to make the equation. It's so quick because it goes through the origin. For the review assignment, we're going back to page 301. We were given some ordered pairs, which are dots on a grid, and we're asked, where is the midpoint? So to find the midpoint, we have a formula. You add together the x-coordinates and divide by 2, and then you add together the y-coordinates and divide by 2. Another way to say that is you're averaging those numbers. This is the x1, this is the y1, this is the x2, this is the y2. So our answer for the midpoint will be 1/2 plus 1/2, all divided by 2, and then -1 plus 4, all divided by 2. Let's see what this answer makes. 1/2 plus 1/2 makes 1, and 1/2 makes 1/2. -1 plus 4 makes 3, and 3/2 makes 3/2. Or you could do a mixed number, 1.5. Question B, we're asked to find the distance between those points. To do this, we use the distance formula. In the square root, it goes x2 minus x1 squared, and then it goes y2 minus y1 squared. Let's make some substitutions. x2 is 1/2. x1 is also 1/2. y2 is 4. y1 is -1. 1/2 minus 1/2 makes 0, and 0 squared makes 0. 4 minus -1 makes 5, and 5 squared makes 25. So this is the square root of 25, which is equal to 5 units. On a grid, these two dots are 5 units apart. Number 14, we're asked to find point A if this is the midpoint and this is the other end of a segment. It's kind of like if there were 3 dots in a straight line and point M was here and point B was here, we would want to find that missing dot. To do this, let's use the midpoint formula. The midpoint is equal to x1 plus x2 over 2 and y1 plus y2 over 2. Now let's substitute. We actually know what the midpoint is. We can put in -6, 2. And over here, we don't know what x1 is because that would be the x-coordinate of point A. That's the one that's missing. But we do know what x2 is. It's a -3. We don't know what y1 is, but we do know that y2 is -1. Now let's create 2 equations out of this. First, let's work with our x values. The x1 plus -3 over 2 has to turn out to be -6. Let's solve this. First, multiply by the 2. We get -12. Then add 3. We get -9. Now let's work with the y values. The y1 plus -1 over 2 has to be equal to 2. I'm getting the 2 from right there. Earlier, when I was working with the x's, I was getting the -6 from right there. Now multiply by 2 on both sides to get 4, and then add 1. to get 5. So our unknown point, point A, has an x-coordinate of -9 and a y value of 5. We have a way to check if that's correct. Remember how the midpoint is in the middle between A and B? So let's check, is -6 in the middle between a -9 and a -3? Let's check our y value as well. Is 2 in the middle between a 5 and a -1? Yes, it is. Number 16, we're given 3 ordered pairs. We're asked to graph them on a grid. So here is 6, 4. Here is -2, 4. And here is 2, 7. And now we're supposed to connect them with segments. This creates a triangle. In question A, we're asked for the perimeter of the triangle. So to find the perimeter, you have to know how long all the sides are. The bottom of the triangle is horizontal, so it's easy to get its length. It stretches from a -2 across to a +6. That's 8 units long. But the diagonal ones are a little harder to figure out how long they are. We need the distance formula for those. So let's do the work right here and figure out how long this side is. Distance equals the square root, and then we're going to work with x's and y's. Remember that this point is the 2, 7, and this point is the 6, 4. In the distance formula, you're subtracting the x's. You're finding how far apart the x's are. So from a 2 to a 6, that's 4 units. Then right here, you're subtracting the y's. You're finding how far apart the y values are. Between a 7 and a 4, that's 3 units. So this makes the square root of 25, which is 5 units. Now we know how long the diagonal side is. We can even label a 5 on it. I want you to notice that the left side looks symmetrical to the right side. So without showing the work, that's also a 5. Our perimeter is 5 plus 5 plus 8, 18 units. Now in question B, we're asked, is this an isosceles triangle? Well, does it have 2 equal sides? Yes, it does. In question C, we're asked, is it a right triangle? Are any of the angles 90-degree angles? No, they're not. This one here and this one here look to be acute angles, less than 90 degrees. And this one up here seems to be an obtuse angle, something more than 90 degrees. Because it's not a right triangle, we get to skip the thing about area. For number 22, we're given 3 dots, and without graphing them, we're asked to show that they're collinear, that they would line up in a straight line. For question A, we're asked to use slopes. If the dots are collinear, then the slopes between any 2 of them will be constant. So let's first find the slope from R to S by using the slope formula, comparing the y's, comparing the x's. Remember, you compare the y's on the top and you compare the x's on the bottom. What is the change in y? From a 6 to a 12, it increases 6 units. What's the change in x? From a -1 to a +2, it has increased 3 units. 6 over 3 is 2. Now let's find the slope of ST. Again, using change in y over change in x. From a 12 to a 0, it has decreased 12 units. From a 2 to a -4, it has decreased 6, and this reduces to 2. Now let's find the slope from R to T. From a 6 to a 0, it has decreased by 6. From a -1 to a -4, it has decreased by 3. And no surprise, it reduces to 2. All the slopes are the same, so the dots must line up in a diagonal line. Now question B, let's do the problem again, but use distances. So first let's find the distance from R to S, using the distance formula. The change in x was 3 units. We had already figured that out over here when we were doing slope. We found the change in x. We had already done x2 minus x1, and we got an answer of 3. Now the change in y, we had already done that over here. We got an answer of 6. So this makes the square root of 9 plus 36, which is the square root of 45. Now let's find the distance from S to T. The change in x was negative 6 units. And the change in y was negative 12 units. Negative 6 squared is 36. Negative 12 squared is 144. And 36 plus 144 makes a 180. Now let's find the distance from R to T. Remember in the distance formula how it's x2 minus x1 squared, y2 minus y1 squared. You're finding the difference of the x's, the difference of the y's. That's what we did when we did slope. The difference of the x's turned out to be negative 3. And the difference of the y's is negative 6. This makes 9 plus 36, which is a square root of 45. Well, what do you do with these results? The idea is that if you take the two shorter lengths and add them together, and if that is equal to the longer length, then that meant that the dots must have lined up in a straight line. So let's take a calculator and get the decimals for these. Square root of 45 is about 6.7 when you round it. And the square root of 180 is about 13.4 when you round it. 6.7 plus 6.7 is equal to 13.4. This answer checks. The last question is one of the word problems. We're told that we have a building, and I tried to draw the building. It's this rectangle shape. We're told that there's a ladder leaning against a building. I tried to draw a ladder over here. I know it doesn't look very good, but I'm not a good artist. And we're told the ladder is 25 feet long, so on the diagonal thing that is the ladder, I wrote 25 feet. We're told the bottom of the ladder is 17 feet away from the building, so across the bottom here I labeled 17 feet. We're asked, how far up the building does the ladder reach? And so on the vertical side of the building, I wrote an X. Do you see a right triangle shape within my drawing? Right here. Because it's a right triangle, we can use the Pythagorean theorem, which in symbols is c squared equals a squared plus b squared. The c is the diagonal side of the triangle called the hypotenuse. The a is the altitude. The b is the base. Let's make some substitutions. For the letter C, fill in 25. For the letter A, fill in X. For the letter B, fill in 17. Now let's evaluate this. 25 squared makes 625. 17 squared makes 289. Now subtract the 289 to get the x squared alone. We get 336 is equal to x squared. Well, how do you get the x by itself? How do you remove squaring? That operation is called square root. So we want to take the square root of both sides. The square root of 336 is about 18.3. And we're told that that distance is being measured in feet. So here's how high up the wall a ladder can reach.